The Command Line Heroes, we want to do a talk on Unix philosophy. Quick about me, I've covered some bits already. I'm Chinmay185 on socials. We talk more on software and reliability engineering. I like engineering in general, and the best part that I like about engineering is the trade-offs and how do you think about systems, right? I also love psychology in a sense of how humans behave, what motivates people, what puts them off, stuff like that. Very pop psychology, not really deep psychology stuff. I love percussion. I play tabla, and there's this very old 25-year-old game now, I think, called Age of Empires that I love. The second version primarily. That's just a bit about me. So quickly getting started in Unix philosophy, what we want to cover is a few things. So I'm not sure. So if you search for Unix philosophy, you will find a page which I think is a cat B or some cat B website. It is not accessible, meaning that it's such a old page that I think it's no longer maintained. But then there is another page that will give you the same stuff, which has a bunch of rules. So the origins of Unix philosophy, again, quick history. Unix, I think, started in Bell Labs way back, I think, 55 or 60 years ago, maybe, I don't know, 1970s, 60s, that time, probably. And then Doug Malroy, a few other folks, and these are, who here, by the way, has heard about solid design principles? Okay, wow, so many, right? So, I like to think of Unix philosophy. I don't know if it's right or wrong. Aditya can kind of help me correct. I like to think of Unix philosophy as solid design principles, the origin, the genesis of solid design principles in some way. Because I see a lot of similarity between solid and Unix philosophy. Unix philosophy goes way more than solid. Solid becomes a bit more prescriptive. Unix philosophy is more generic. It's more meta in that way, right? So what does it talk about? So it talks about a few ideas or rules or thought process or way to do something, way to write programs, right? So the first, I mean, they're not in a particular order. I've just covered a couple of rules. I'm not going to cover all of them and bore you till death. We'll try to hopefully make it more relevant for you and make it more interactive. So one is the rule of responsibility, right? So fundamentally, like you see, make each program do one thing and one thing well. To do a new job, you want to build a new program. You don't want to complicate an existing program with more features or more unnecessary, unrelated stuff, right? So this, in my mind, is akin to, if you think solid, single responsibility principle, right? Now, responsibility here is in quotes, because everybody likes to say, oh, single responsibility means one function, one line, one class, one module. Like universe has a single responsibility. We could even start from that to an atom has a single responsibility. Well, maybe not according to quantum physics, but maybe that's a separate point. So idea is responsibility is very buzzword. It's a very fuzzy word. So that's why you have to apply it in some context, right? So to give you an example of single responsibility or what it means to write each program do one thing well is, think listing files. ls, I'm sure everybody or most of you know the command, and its options, and versus you want to find a particular file. At the face of it, if I think from REST API point of view, right, I would think that listing and finding is kind of similar if you think about it, right? I am listing a bunch of orders or I'm finding from my bunch of orders. So in that way, it sounds very similar. So in a classical, traditional or typical maybe REST API kind of application architecture, you would end up writing all of that functionality in one way. Although if you peel a little bit more, what you will realize and what you will see is that listing is semantically kind of different from finding, right? Finding is you want to, it's like more of a search functionality, whereas listing is more of a, like, the items, you just need to list them in some particular order, right? So in that way, there are options for file listing in Linux. You'll do it with ls, and it's multiple options to list files, but there is a separate command for finding. If they had not done it, then we would have a one complicated giant command. I think ls is probably the most complicated command, I feel, with most options. So that's the idea, that making each program do one thing and having to write a separate program kind of goes in hand with rule of separation. Wow, this is a way too big thing, but that's okay, I guess. So separating policy from mechanism, right? Separating interface from engine. Again, think of it as single responsibility and interface segregation in solid. I like to maybe give this example. You see the clock at the back, right? What is a clock? What's the interface of a clock? If I were to ask you again from object oriented, because I'm guessing most of you are familiar with object oriented kind of paradigm, etc. So what's an interface of a clock? Any thought? Face. So what does by interface I mean? What's the functionality that a clock provides? In that way, what's the method? If you were to write a clock as an interface in any programming language, what would be a method that you would write in a clock?
Get time, set time.
Show time, get time. So essentially, it tells time, right? And what are the implementations of that interface? What could be the implementations of that interface?
Second hand, minute hand.
Atomic clock, digital.
Yeah, second hand could be one way. That's more the internal mechanics or the parameters of how the clock maybe operates. But more broadly, if you think, it is whether it's an analog clock, whether it's a digital clock, whether it's an atomic clock, whether it's a sundial. Yeah, like you see, like so interface of all of these clock is to tell time, but the implementation is different, right? And based on the implementation, you get different precision, different mechanism. So that's the idea, that you kind of separate your policy, which is the clock has a policy is to tell time, and mechanism is a very specific implementation specific thing, right? So again, I'm trying to apply this to hopefully the stuff that you might be doing every day and not going back to Unix. How do you apply this to Unix? Yeah, interesting. I don't know. I'll come back to that. I couldn't find an example. Good.
Windows is an example.
Okay.
So, if you look at Windows, there's only one kind of interface, the buttons and all of it is same. But in Linux, you have different window managers. So the mechanism of showing something on the screen is separated from what to show on the screen.
Everything is a file interface is that way.
Yeah, I mean, again, I feel
What is the file is different because you have a socket, you have a thing on disk, or whatever.
correct. So we are kind of covering exactly. So I feel these are, again, it's hard to separate them individually because all of them kind of connect and talk about similar things at the high level is what I feel. So again, rule of composition, this is where we are getting to that. Design programs to be connected to each other, right? And how do you connect one program to another? You typically take input or output of one program and pass it as an input to another program. But imagine, like, I don't know what's the input and output going to be. So this is where, again, you might have heard this ad infinitum. Everything in Linux or Unix is a file, right? So pipes, socket, your file descriptors like stderr, err, stdout, sockets, even, literally devices that you see, you can list them, processes, you can list them. All of it is kind of represented as a file kind of interface. Again, interface, not necessarily meaning file as in a classical like file that you think of like as a text file, right? So think of it more from an interface and functionality point of view. So again, typically for Linux or Unix kind of systems, for command line, primarily it means, like you see, write programs that handle text input, text output. So that's a common exchange mechanism between programs. If I was writing binary, then, or I was writing not text but something else, I was writing to a different file instead of even outputting via stdout, the integration between programs would be very difficult. Maybe a dumb or a stupid example, but still counts, I think, is if you do find dot minus type f, it's going to list all the files in that directory, and then you can pipe it to a separate utility called wc, which does word count, and you say minus l is number of lines. So it's going to give you a number of lines. So essentially, this is going to give you the number of files that are listed. You probably want to do it with a different command, but you can do it with, like, this is the chaining and the pipelining part of it. The reason you can connect these two programs together is because you have a unified text interface. Right? I'll move quickly, and this is the rule that I love. When a program has nothing surprising to say, it should say nothing. So I'm not going to say anything about this. We are moving on. But we should talk about it later if you want to talk. Again, maybe to give a one-liners for people who are new and who maybe don't get the joke. You don't want to have a file created successfully kind of message. Okay, you want to just say exit code 0. Right, that's it. You don't need to print, oh, I created this file that you asked for. Fine, I don't care. Like, you don't need to mix logging with command output, right? It causes confusion, which gets to, again, the connectivity part. All of this kind of relates in my mind each other. So again, example of find dot, if you see, so I'm jumping ahead. Essentially, output of every program can become an input to every other program and vice versa. Think that way. So design composable, modular, futuristically extensible programs in that way, right? So you don't want to say file created successfully. Like touch file.txt, if you do, it doesn't log anything. It just, boom, it's created file. If you cannot create a file, we'll come to the okay, it's coming up ahead, so maybe I'll cover it that time. But if you cannot create a file, you want to fail as noisily as possible, right? That, hey, the file couldn't be created, permission error or something like that, right? Like, you know why you can't create a file in that case. So again, the other rule is super important. Again, we've highlighted this a lot in our higher level programming design, but I believe if we follow this, it will become very easy or very interesting for us to build programs. Don't insist on interactive input, right? Because interactivity kills composability in the sense of you have to wait for the user or some external input, a side effect to occur, right? So example, imagine if you do ls on any terminal and you say enter, right? It doesn't ask you which files do you want to list, or do you want to list the directory also. Like, it just lists the files in the current directory. Again, maybe dumb example, but idea is, don't look for interactive input unless you absolutely have to, right? Or provide interactivity via a flag or something like that. Again, if you really have to, which is where interactivity can be done in Linux by using stdin. You can kind of take the input stream and you can have another output stream, pipe it to that input stream. So essentially, that's how you connect the two pipes together. To see how much time we have. Okay. Rule of repair, we kind of talked about it. If you fail as noisily with a lot of details of the error message, pointing exactly what's the problem. For example, in case you can't create a file, permission error, if you're trying to list something, file not found, stuff like that, right? Rule of optimization is, you, again, I love this, and I keep iterating this to almost everyone. Again, this I will say from a initial I like to apply this to product building in general, that when you are building something from scratch, you shouldn't think about optimizations or perfectness from the day one. What you should instead optimize for is the speed of iteration. Like, how fast can you iterate and make something live, and again, see how it works in real world. Do people want it? If not, then why don't they want it? Analyze, and then again go back to iterating. So the speed of iteration matters more than a perfect product or a perfect program, right? So don't optimize. Again, there is a quote by premature optimization is the root of evil, etc. There is further context in that, but we'll skip that for now. So again, I like to call it in a simple way: make it work, make it better, in that order. You don't want to make something better, but it doesn't work. Like, I don't want to have an amazing microservices architecture, but I can't do a happy path flow. Like, what good a program is if it doesn't function properly, what it's supposed to. Instead, I would happily prefer a simple monolith that actually does the job. It doesn't scale beyond 10 users, that's totally fine. It's fixable problem. But something that doesn't even work at the start, even if it's scalable, nobody's going to use it. Then rule of diversity is again, I love this. There is no silver bullet. Who here has heard about this term called silver bullet? Like some of you. So there is a paper by Fred Brooks, way back, old paper, exactly with this title. There is no silver bullet. So where it says again, no methodology, no practice, no tool, no language is a one-stop solution for everything, right? And it makes a case by giving a lot of examples, and we've seen these trends and fads in software industry, right? Object-oriented programming, when it came, it was sold as a panacea that, hey, this is going to solve all of your problems. Relational databases, XML at one point in time, people who are old enough to remember. New age would be GraphQL. LLMs. Yeah,
Oh, right.
like that's like, that's true. Yes, LLMs. So essentially, no, and even from practice or thought process point of view, agile. Like there is a massive thing about, hey, agile is the way to do. Like if you are not agile, you're not going to make it. And everybody is using agile as a noun instead of using agility as an adjective or the act of being agile. They think of agile as with capital A, with saying, okay, you have to be agile, and for that you need to follow some bunch of rules and practices and things. But again, what do you end up doing at the end of it? That's up for grabs. So essentially, idea is there is no silver bullet. You have to apply trade-offs, and this is the part that I love about engineering in general. That there is no silver bullet, so you have to really weigh pros and cons of things, right from small decisions to all the large decisions that we do every day. I think last one is the rule of extensibility. So design for the future because it will be here sooner than you know it. In a sense that you want to balance that I will design a software that can work. So I like to explain it in this way that design your program code software so that it can work well for today and can scale for tomorrow, right? It doesn't have to scale for tomorrow right now. One, because you don't know what tomorrow looks like. We don't know what metric or what parameter will lead to more scalability, right? Is it IO intensive? Is it CPU intensive? The kind of workload that you have. Is it is your one use case going to trump every other use case in the product kind of sense, right? So you won't know it, and you don't know it typically. So idea is to, again, that's where again goes back to iterating things. You start iterating one thing at a time, use it, see how it works, and then you build iteratively essentially. So I think, yeah, that's it from my side. I wanted to do this as a quick talk so that we give time for a deep talk for Aditya, and this sets the primer for something. If I can get it working later, I mean, I got it working yesterday, but I don't know if the printer is running right now, and I didn't get time. What I would have loved to show, and maybe I'll show it later, is you can just do whatever cat file.txt, or you can forget cat. You can just do lpr file.txt. It is going to print on the terminal, on the printer actually that we have inside the office. So again, just to have a physical artifact of computers controlling a physical thing, it just is a good demo. But maybe I'll try to, because it's hard to get printers working.
For now, you can just type in say and whatever it is.
Oh yeah,
That will-
I don't know if
people have not seen it.
I don't know if I have say. You have, okay. So
Hit us.
Pipe this only. This MD.
To the pipe your presentation to say.
okay, yeah. Give me a second. I'll change the font. I know it's hard to read.
SPDF. I don't know which one.
Say will take, yeah, cat this and then say.
Welcome to Command Line Heroes, a talk on Unix philosophy by Chinmay Naik, 1 to N. About me, founder and CEO.
That's
But you can change the voice, you can change the cadence, you can change
I could have just
this.
I could have let my AI speak for itself.
Say this is a like I think say was Manberg says I think they made it in like 1971. This is one of the first programs they did.
say is okay. This is doesn't say the history.
I say, but it's one of
Yeah,
the
yeah.
programs.
So I think we will cover some of these super fun and random and geeky commands. Like I did one presentation way back again 10 years ago around Linux command line where it was more hands-on, right? Like talking about, hey, if you want to find this, if you want to solve this use case, which we end up doing every day, how would you do it with Linux? And then some weird random commands. I don't have it installed, I think. There's an alias that I created called train, and then when you do train, it a proper like train appears on your terminal. It's like some fun stuff, but okay, maybe some other time.